Welcome to lesson 10 of Fundamentals of Chemistry. In this lesson, we are going to look at SLOs 1.4.1 till 1.4.3. We are going to look at empirical formula, molecular formula. We will be calculating empirical and molecular formulas with the given data. Let's look at what is empirical formula. For a compound, we have two types of formulas. One is called empirical formula and the other one is called molecular formula. Empirical formula is the simplest formula we write for a molecule. So it gives you simplest ratio of atoms that make up the molecule. So whenever you're writing the simplest ratio between the atoms that make up that molecule, that is called empirical formula. And when you write exact ratio of the atoms that make up that molecule is called molecular formula. What do we mean by this? Let's take example of glucose. The molecular formula of glucose is C6H12O6. This tells you that the molecule of glucose has 6 carbon atoms, 12 hydrogen atoms and 6 oxygen atoms. This is molecular formula because this is giving you exact ratio or exact number of atoms that make up the glucose molecule. So we know that the glucose molecule has 6 carbon, 12 hydrogen and 6 oxygens, and that is why this is your molecular formula, which is telling you the exact number of atoms that make up the glucose molecule. If you want to find out the empirical formula, if you want to look at the empirical formula, what is it going to be? We are going to simplify this formula by cancelling out it with the same 6. For example, if I cancel out with 6 all the atoms by the number 6, we are going to get the simplest ratio between them, and the simplest ratio is going to be 1 carbon, 2 hydrogens and 1 oxygens. What I have done here is I have just simplified this whole molecular formula, and when we find out the simple ratio of the atoms in the molecule, that is your empirical formula. So CH2O is the empirical formula because it is not giving you exact number of atoms, it is giving you simplified number of atoms, whereas the molecular formula gives you the exact number of atoms in the formula. Let's look at the differences between the empirical formula and the molecular formula. So by definition we know that the empirical formula is the simplest formula, okay, and molecular formula is the exact formula that tells you the exact number of atoms in the molecule. What is the theory behind empirical formula? It gives you the simplest ratio of atoms, whereas molecular formula gives you the exact number of atoms. Molecular mass, you cannot find out the molecular mass with the help of empirical formula because empirical formula does not tell you the exact number, so you cannot find exact molecular mass of any compound. For example, इससे पहले हमने जो example लिया that was glucose. You cannot find out the exact molecular mass of glucose with the empirical formula of glucose, but you can find out exact molecular mass with the help of molecular formula. What can you predict with the empirical formula? You can predict the type of atoms in ionic compounds or in polymers. You can predict the type of atoms, that what atoms make up the compound, whereas molecular formula can be used to find out oxidation number of the atoms. What is the use of empirical formula? The empirical formula is used for simple molecules, crystalline ionic compounds and polymers, whereas molecular formula is used for covalent compounds, macromolecules and other ionic compounds. We are going to look at what are ionic compounds, polymers and covalent compounds later on in the chapter structure of molecules, but right now you just have to remember that the use of empirical formula is for the ionic compounds or the simple molecules, and molecular formula is used for complex molecules or the molecules that have covalent bond. We have an example and we are going to look at how we calculate the empirical formula and molecular formula. So let's look at the question. We have this question: a compound is 43.7% phosphorus and 56.3% oxygen by mass. You are given with percentages of some elements. We have phosphorus, which is 43.7%, and we have oxygen, which is 56.3%. What do you have to do? It has a molar mass. The compound, which is unknown, has a molar mass of 283.88. So the molar mass is given. What are the empirical and molecular formulas of this compound, which is unknown, and you have to find out the empirical and molecular formula both. What are the steps that we are going to apply over here? The first step is we write the elements. What elements are given? We are given with phosphorus and oxygen. So let's write the elements first. We have phosphorus and oxygen. The second step is divide given percentages of each element by the molar mass. So what we are going to do, we are going to write down the percentages that are given. Phosphorus is 43.7% and oxygen is 56.3%. What do you have to do? We have to divide by molar masses of these elements. So we know that the molar mass of phosphorus is 31 and oxygen's molar mass is 16. So once we divide that, we get 1.40 for phosphorus and 3.51 for oxygen. What are we going to do next? Divide divide all the masses all by the smallest number and round off. We have to look at which number is smaller in both of them. 1.40 is smaller than 3.51. We are going to divide both the numbers with 1.40. What we are going to do? We are going to divide 1.40 by 1.40 and 3.51 with also 1.40. What are we going to get? We are going to get 1 for phosphorus and 2.5 oxygen. Okay. Now we have to round it off. How are we going to round off? We are not going to round off the way we usually do in the classroom. We are going to multiply it by 2. Okay. So the way we are going to use for rounding of these numbers is by multiplying with 2. So once we multiply 1 by 2, we get 2 for phosphorus, and 2.5 multiplied by 2 is equal to 5 for oxygen. Okay, so we get 2 phosphorus in the end and we get 5 oxygens. Now what we are going to do, we are going to write down empirical formula, which is step 4. What is the way of writing down empirical formula? We know that we have 2 phosphorus, so we write P2, and we have 5 oxygen, so we write O5. This is your empirical formula. Now what we are going to do, we have a step 5, which is find empirical formula mass. What we are going to do, we are simply going to add the masses together. We know that the empirical formula has 2 phosphorus and we have 5 oxygens. Okay, the mass of phosphorus is 31 and the mass of oxygen is 16. So 2 multiplied by 31 plus 5 multiplied by 16, which is equal to 142 grams. So 142 grams is the empirical formula mass. The mass that we get with the help of empirical formula is called empirical formula mass, and this is a step 5 to get empirical formula mass, which is 142 in this case. What is step 6? Divide molecular formula mass by empirical formula mass. If you look over here, we have molar mass or molecular mass provided, which is 283.88. What are you going to do? We are going to divide that molecular mass 283.88 by 142, which is our empirical formula mass, and to get a factor which is called scaling factor. So once we divide the given molar mass with the empirical formula mass, we get the scaling factor. Okay, so we simply do what? We divide the given molecular mass by the empirical formula mass that we have found out, 142, and we get 2. 2 is the scaling factor. It is called scaling factor. Okay, now what we are going to do, multiply empirical formula mass by scaling factor. This empirical formula mass is P2O5. We are going to multiply it by 2 and we are going to get molecular mass in that way. What is it? We have empirical formula, which is P2O5. We multiply it by the scaling factor, which is 2. We get P4O10. Okay, so P2 when multiplied by 2, it turns into P4. 2 2s are 4 and 5 into 2 is O10. Okay, so P4O10 that we have found in this way is called the molecular formula. So this is how we get empirical formula and molecular formula. You need to learn all these steps so that your question turns easy. We have another question, another example. Styrofoam is a polymer. Styrofoam is a polymer. Polymer is actually a big molecule. Okay, polymer means a big molecule. Just need to remember right now. You don't need to go into the details. Polymer made from the monomer styrene. Elemental analysis of styrene shows its percentage composition to be 92.26% carbon and 7.75% hydrogen. So we are provided with two elements and their percentages. Carbon is 92.26% and hydrogen is 7.75%. Its molecular mass is found to be 104.15. So we are provided with molecular mass. What are the empirical and molecular formulas? We have to find both the formulas. So same steps we are going to apply over here. We are going to write down the elements first. We are going to write down the percentages that we are provided with: 92.26% carbon and 7.7% hydrogen. We are going to divide these percentages by the masses of these elements. The mass of carbon is 12 and the mass of hydrogen is 1. We all know this. We should know the masses of the elements before doing these numericals. So once we divide them, we get 7.68 carbon and 7.75 hydrogen. What we are going to do, we are going to look which number is smaller in both the cases. 7.68 is smaller and 7.75 is greater. So we are going to divide both the numbers by 7.68. What are we going to get? We are going to get 1 carbon and 1 hydrogen. 7.75 divided by 7.68 is 1.00 something. So you are going to write it 1, okay? We have carbon 1 and hydrogen 1. And what is the next step? We know that we write down empirical formula, and the empirical formula is CH. Why don't we write 1? We don't write 1 C1H1. We don't write like that. We just going to write down CH, okay? So CH is the empirical formula of styrene. Now next step, we know that we find out empirical formula mass. You need to learn all these steps. We have 1 carbon, as we know the mass of carbon is 12, and we have 1 hydrogen, and as we know that the mass is 1 for hydrogen. When we add the masses together, we get empirical formula mass, which is 13. Now what we are going to do, we are going to find out the scaling factor. We know that we are provided with molecular mass, which is 104.15. We divide that by the empirical formula mass, which is 13. You get the scaling factor 8. Now multiply your scaling factor with the empirical formula. Scaling factor is 8. We have empirical formula CH. Once we multiply them, we get C8H8. So C8H8 is your molecular formula of styrofoam, okay, which is C8H8, okay. Your task is to find out the molecular formula for these questions. We have to find out in this question, we have to find out the molecular formula. You are provided with the answer, so match your answers after you are done. And this is your task 2, which is about vitamin C. In this one you have to find out the molecular formula as well. So we have to find out both the formulas, the empirical formula and the molecular formula, and you are provided with the answers also. Match your answers, and if you have any problem, you can ask me in the comment box. Meet you in the next lesson. Till then, Allah Hafiz.